Live on YouTube. I'm just preparing to live stream. Just give me a minute.
Yeah. Fine. This is a continuation with the last session, right, my Vaibhav?
I had a different plan in my mind for this session, but I'll continue from the yesterday's session.
Fine, Vaibhav. Please, you carry on. You take over the session. Thank you. Yeah.
Okay. So shall we start? So today my topic was design thinking process and 3D modeling in robotics. So I had planned about 40 slides on design thinking process, and we did little bit of 3D modeling, and I understood that it requires more time for you guys to even pick up that skill and get to know that interface better. So I'm extending that fusion session. So I'll keep the theory bit and the design thinking process planned to be very short. I've planned it that way. So hopefully this is a more informative session for you guys. So yeah. So what is design? Can anyone please try to answer what is design? Once they answer, they can go unmute and again.
To give a proper structure of a thing.
So it may be a sketch for, you can say a sketch, basic sketch to make something.
It can be the layout of your plan.
It is a structure.
Okay. So design has a lot of meaning, and it applies to a lot of areas. When it comes to architecture, design means something. When it comes to drawing, design means something. When it comes to shape, form, design means something. So design as a term, it is a process. So it is a process of finding the best possible way to solve a problem or address a requirement. Okay, design in robotics is about creating that robot so that it is the best when it has to solve something. Say you are building a robot to navigate on the moon, so you kind of add those features and design the robot in such a way that it navigates through the moon, it communicates with the base station better. So design is a process of finding the best possible solution for that particular given problem. So when it comes to say drawing, so drawing becomes an execution part. It is an execution part, and how good the drawing looks and the aesthetics of it is, you can also call that as design. So every design has a particular purpose, a specific purpose to it. So your bottle cap, it has a screw mechanism. There is a particular purpose to it. The grooves that so you would have seen Bisleri bottles or plastic bottles, right? Use and throw bottles. There will be ribs around the bottles. So there is a particular reason for that. So you would have seen corrugated boxes with corrugated is the carton box. So the middle layer of that corrugated box will be like zigzag. So there is a particular reason why they had zigzag and not just 3-ply. They had one corrugation attached. So design, everything that you look around will have a particular purpose. It is made of a certain material because of some reason. And you look at nature, everything has a purpose, and it is designed beautifully. You can't think of a better way of designing this earth than what it has evolved itself to be, right? So design means it is a process. There is a particular way of doing things, and there is an outcome that you expect out of design because it is a process. And you look at these two images, you would say you are serving food to these two animals, right? If you design a vessel that can contain the food, it is good for one animal and not for the other. And you look at the second image, the crane is in a better position and it is enjoying its food, and the fox is wondering how to eat it. So design is also about experience and the user. It has to be human centric, and it has to be for that particular purpose, whether it is serving that purpose and how well it serves. See, if I design a staircase and ask somebody on a wheelchair to climb it, it is bad design, right? You might have used the best of marbles. It looks aesthetics, everything. I mean, the railings are aluminum, gold plated, all of that, but a user cannot climb it. Okay, the steps are pretty long and high, and it becomes very difficult. You have to take 2 steps to reach the next step. So those are bad design examples. So you've got a good design that is only possible if you have designed it for that particular user experience and for that particular human being. And there are few designs which were best at those particular times. So if you go 20, 30, 40 years back, you would see a phone like this, and phone like this is a luxury, and it looks really nice, and it used to look really nice. But would you use the same phone now? No, right? Design has evolved. You look at say 500,000 years ago, there are a bunch of people playing football, and what do you know, understand from this? They are now trying to kick a ball, and the ball is made of stone. 1,000 or 2,000, 3,000 years ago, they would not have found out the material itself and how they would do that football. So they've used a stone, and their legs are hurting, right? So design is also specific to the timeline, era, generation that we are in. So 10 years ago, when I was building robots, I was using 8051 microcontrollers, and I had to use 2 boards, one to program the microcontroller and other to run the microcontroller. Then we understood there is something called as erasable programmable memory, or EEPROM. Then we used that, and then we used the same board with some configuration. Then we started. So design always evolves. It evolves with time. Now we have Arduino. You just have to connect one plug, and you can write code, and it gets deployed. There is no hassle, right? Everything is evolving with time, and everything is supposed to make user experience great, right? We used to grind it with a grinding stone. Now we have mixers, food processors to do it. So it is possible because we have electricity, we have other manufacturing techniques wherein you can use those things and leverage and make user experience better. But in the process, we have created a lot of problems. The problems that did not exist 1,000 years ago, there are problems that we are facing now, because yesterday we committed one problem. So plastic is one such example. For everything we are bringing in plastic, for everything we are bringing in some other use of the manufacturing facility, wherein it is emitting carbon and it is making planet inhabitable day by day. So design process is also about not just the era, not just getting the user experience right. It is also about the long-term thing, how durable it would be, what are the things that has to happen, right? If you have and design thinking process. See, because I'm telling design is itself is a process, and when you say design thinking process, there are various steps. The first 3 categorization or 3 steps in design thinking process is immersion, ideation, and implementation. So you look at, if you want to start a new business, or you are an entrepreneur, you want to start something new, or you have to build an app, or you have to build a robot, or you have to design a new water bottle, whatever that is. So you have to, look into the problem, or you have to first identify the problem. That is only possible if you are in the field experiencing it. So immersion is the first step. The second step is, now that you have experienced the problem, now you can, imagine and find out how you would, solve such a problem. And that is where the ideation phase happens. And then once you have an idea, you have to implement. So for that implementation, you need some tools. So for robotics, you can use 3D modeling and you can create objects from 3D printer, laser cutting, some other manufacturing techniques, injection molding, right? So there are techniques wherein tools becomes important, and so that you can implement your idea. And if you are looking at an application, suppose you want to build an app like a social media interaction app like Facebook or Instagram. So first and foremost is you have to know what is it that you are trying to address, and then you have to ideate as to how my app would be better and how my app would stand out. And then you have to have prototypes. You can't simply start writing codes. Put my logo here, put my form here, put my profile photo here. You can't simply start coding in HTML or CSS file. Instead, you can have one layout. You can even hand draw it with the paper and have one sort of an idea as to how this will come out once I do the entire development of that code. So there is ideation phase. If you go within these three domains, immersion, ideation, implementation, we get this infinite loop of design thinking. So starting with ideate or define. So now that we know there is a problem that we want to address, what is the very next thing that we have to do? We have to come up with the solutions. So what are the solutions that will ensure that we are addressing those? One second. Okay. So once we know, we have defined the problem statement, we have immersed ourselves to find out what are the problems that anybody would face, be it in app development or starting your own company. We have defined what is the problem that we will address. The very next stage is okay. The very next stage becomes, how do I solve that problem? Once you have a basic idea as to how do I solve that problem, now you can prototype. Prototype is the phase wherein you start sketching, you start doing 3D modeling, you start simulations, you start prototyping with a pen, paper, or an app wherein you can sketch, or you can if it is an app, you can go to prototyping tools for an app. You can visualize how the app will end up being even before starting to do it. So once you have this thing, if you find again you're not solving that problem effectively, you have to go back. So design thinking process is not just ideate, prototype, test, empathize, define, all of that. It is a continuous process. It is in a loop. Every time you come up with an idea, you can go back and look at, introspect and see if you have really understood the problem, if you have really trying to fix the problem for that particular user base. um, so it is an iterative process, it is an evolving process, and from immersion to implementation, you can go back and forth and come up with the ideal solution. So that is the design thinking process on the whole. For businesses, or be it any business or a robot design, you have to look at these three aspects. So people desirability, business viability, technology feasibility. So whether you have the technology to do it, whether you have the money and resources to do it, whether you have the team and the desire to work on these two things, right? Once you have these three, you will find one synergy, and that is where innovation can happen with design thinking process. So you got to keep these things in mind, whether you have money and other resources to execute a problem or identify and solve that problem, whether you have the know-how, the technology and the feasibility to solve those things, and whether you have a team that you can implement the whole thing. And once you have a team, then you can start innovating, and that is where you can say put the empathize, ideate, design, that entire sequence of things, and you can reiterate so that innovation really happens. So it could be for an entrepreneur, how he has to come up with the problem statement, and then explain what is the solution, and then come up with the technology, prototype and build. So design thinking at this, that is how innovation is possible. Okay. So we also had a problem at Just Robotics. I'm jumping into the part wherein I'm talking about Just Robotics and experience of me with the team, and how we use design thinking process to come up with the solution that we have built. So we saw the COVID pandemic happening in the month of March. We had the lockdown that was announced. These were the problems that we understood. So the infection is spreading. It is spreading because of social distance. It is spreading because people are not wearing masks. It is spreading because people are still roaming around. And if an infected person goes on touching a lot of objects, or he coughs up when he's driving, or whatever happens, the infection or the virus is there, and you have to disinfect these spaces. So lot of areas like where I work as a co-working space, you have to keep disinfecting these spaces. You can't simply go around keep spraying chemicals. So when you keep spraying chemicals, the surfaces are wet, and you have there are smell, and you don't feel like entering that space. So these are the problems that we saw. These are the solutions that we saw that needs to be addressed. So, and we saw that nobody is ready to do such a thing manually. If they have to spray, they also inhale a lot of chemicals. So what are the so we understood the problem. We were a part of the problem. We wanted a solution for ourselves, and this was the solution that we had. So solution was, we have been seeing since the last 50 years, we have seen how UVC germicidal lamps are used to disinfect operation theaters, used to disinfect medical equipments. And you would have seen how the microwave, the UVC oven is set up so that, used to sanitize the things, say the baby products, the teether, the feeding bottle. They wash it, they boil it, and they also keep it under the UVC lamps. So that UVC lamps kills all the bacteria and virus. So there is an exposure time and a dosage. So we had this mobile robot, which we call it the answer robot. So we had built this some 6-7 months ago, even before the pandemic. Then we understood, okay, so there is a problem where wet surfaces and chemical is used extensively to disinfect. Then we had a solution where we are combining the UVC lamp with our robot, a base robot that moves around, so that you can automate the solution. So we built this UV disinfection robot during the pandemic, and there was a hackathon we participated, and we won first in the global hackathon, where more than 28 countries participated. We won that competition because we were able to build this robot and prototype it very quickly. We used laser cutting techniques, Fusion 3D modeling software. Within a span of 1 week, we had this solution ready. And after that, the thing was to master the solution, to fine tune this solution. So this robot is still operational, and this is a product of design thinking process. And okay, so that's about Just Robotics. There are a lot of smaller ideas that you can tackle. So you would have seen pens and with the refill. If you use a straight refill like this, it will hold, say, 1 unit of ink, right? If you make this spiral, because of the length that has been increased, you can now hold 2 units of ink, right? But look at the plastic it will hold. I mean, the plastic that it uses. So for this, again, there is one housing and one plastic. But now since you have increased it, and it also fits in with the same housing, the plastic housing, the pen can write twice as long. It can hold twice as more ink. So with this design thinking, best idea that I found, how they have increased the mileage of the pen and reduce the plastic waste. So that is one thing. And a lot of water bottles, especially the kids use, it has a straw. The younger kids that they use, they have a straw. And now with the corona situation, when you touch a lot of things, say you're touching things like the straw and then putting it in a mouth, you are literally licking your fingers. That's what is happening when you use a straw. And if you have to do this with the sipper, if you have to put the straw, you're touching those surfaces, which is not good. And you are also in contact with the bottle cap and the surfaces that is exposed. So instead, you can simply do this, where there is a spiral in the straw. You just push it and screw it, and then when you remove it, it pops up. Then you can drink from that bottle. So in the same lines, that is one solution. The other solution is where the bottle is being redesigned. You would have found a little difficult to fill the bottle to the brim when you're filling the water bottle with the tap. So if you just move the bottle cap little to the side, so this is the advantage. You can fill the bottle to the brim. Full bottle is now has water. There are no air inside. The second thing is you don't have to lift the bottle fully. You just have to lift little, and you can still empty the bottle. You can do bottoms up without really doing the bottoms up. So that's the design thinking process, and how it can make our life simple, better, eco-friendly, and how it can solve a lot of problems. So there's another thing that we are seeing is bad posture with work from home and taking online classes. For a lot of time, we are using laptops and things for a longer duration, and we obviously experience some backache because of the bad posture. So just by elevating the laptop a little bit more, you are able to have a better user experience. So laptop stand could be one solution, and this is the solution that we designed and laser cut and built at Just Robotics office. If you just visit our office, you can see this laptop stand everywhere on every table. So we use it, and we also incorporated one small drawer wherein you can keep the essentials like the ID card, some money, and mouse, so that the table looks clean. So this is the laptop stand that can solve your bad posture. And your hands go like this, so it is better user experience. The screen is lifted little above. So this is something that you can design. So I'm jumping now to the hands-on session where I'll be designing this sort of a little simpler version of this laptop stand, and how I can export the file to the manufacturer and get the laptop stand cut, and then I can assemble it. So
Sir, excuse me, sir. Is it still in the designing end, or you have done it and marketed it?
So this is something that we have done. We are not selling this thing, obviously. This is something that we built it for ourselves. Yeah, this is what I've done. See, what we have in store that we are selling is this robot actually. Okay. So coming back to the design thing, see, we are not selling this. But today I'll be teaching how to do this and get this thing done. Right. So today we'll do the laptop stand. We will design the laptop stand. You have any problem, you can ask me. I'll help you design this laptop stand again. Even after the class is complete, you can reach out to me so that we will build this laptop stand.
Okay, thank you, sir.
Yeah. So this robot, can you see my screen? Yeah. So this robot here. So this was built, and there's one small design thinking that we did at Just Robotics. So this was one of the second iteration. This is the second iteration. This is the final one. So in this second iteration, we had given a hole like this. I used to put nut and bolt. Okay. So to remove and access the board, I had to use a screwdriver and a cutting plier. I had to use a screwdriver and cutting plier to remove nuts and bolts that will hold this plate in place. And I had to remove this and then remove the top cover to access my Arduino, and to even charge my battery. I had to remove this. Okay. And this was a little tedious process. We found every time I have to access something, I have to change some connections. I have to remove 2 nuts and bolts, which means I essentially need to have a screwdriver and a cutting plier every time I'm opening this. So we thought this is the final robot. Then we did one more iteration. See, we are going back on the problem and we are seeing whether user experience is better. So we are going back to the ideation phase, and we are coming up with the next solution. We are again prototyping, and now we have put this in production mode. Okay, so here what we have done is we have put one small key that you can simply remove like this, and then slide this open. So we've got two pieces, the key and the lock, and now you can simply open. This is much easier. Instead of using a tool and other things, now you can simply take off this top plate and with these two components, and then you're done. So that is how design thinking process will help you evolve. And when the process is happening, the whole team that is working can also intervene and point out where we are going wrong, and how we can improve on each step. So having this process in place will ensure there is innovation happening, there is streamlining happening, and you're also manufacturing. I mean, you're designing for the manufacturing and for the user, and you're using the right kind of tools, materials, and user experience is better. So it is an evolving process. Okay, so shall we now move towards the hands-on part of the workshop? We got about.
Sir, have you used the wooden filament for this particular computer table?
See, this is not a, see, whatever this is, or the laptop table, this is not 3D printed, ma'am. So this is a plywood or a cardboard that you get in a plywood shop. You just take that plywood thing and go give it to the laser cutting people. So there are a lot of laser cutting people. You just Google laser cutting people around me, you will find a lot of addresses. Just call one or two of them and ask whether you have this kind of a cardboard of this thickness, and can you get it laser cut if I send you a file? They'll say yes. Then they will say what is the setup cost and what is the job work that it will have. So laser cutting is done on the time basis. So if you are getting laser cutting done, they will charge somewhere between 8 rupees to 15 rupees per minute of laser cutting. And you can even tell them what is the speed at which it has to cut. And some people, they cut it very slow so that they will get more money from you, because they can spend more time on cutting it. And with some iterations, you will understand you can cut it a little faster. So you can give one test piece wherein you can ask them, you cut this line at this speed, you cut this line at this speed, and you cut this line at this speed, and you examine how the cut has happened. And then you can decide, okay, you use this speed of laser cutting for my entire design, and laser cut it and give it to me. So setup cost is somewhere between, for every.
So what is the difference between the slow cutting and the medium and the fast? So is there any difference between, like, will there be any difference between the model if we cut it slowly or fast, or finishing will
Okay.
be different one?
Correct. So I'll show you this. This was laser cut. Can you see there is burn marks here?
Yes.
You will not see a burn mark here, but you will see a burn mark here.
Yes,
On this edge, there you can see a burn mark, right? So the laser cutting machine is going fast, and it is not leaving so much burn mark on the straight lines. But as soon as there is a curve, it is slowing down a little, and there is a burn mark, right? And burn mark also gives an effect. See, I'm doing etching so that my logo comes on the this panel, so it looks premium. And when we are doing this laser cutting or etching on this, if we have here the infill is little, so there are few lines. Here the infill was more, so you can see the depth and the burn marks also has increased. And sometimes if the you want these slots to be completely come out of the panel, you don't want the thing to stick there, so you have to use little you have to slow cut it. You can't simply go fast.
Is that only the burn mark is the difference, sir, or the finishing, the smoothness, everything matters?
See, if you cut it very fast, it won't reach that depth. Since the thickness is 3 mm, so if it is going really fast, it will simply etch, because it is not getting enough depth to it, right? Laser has to penetrate the entire surface through and through to get a cut. If you are going very fast, you will not get it. So this is something that you should not be worrying so much. because usually the laser people who have laser cutter, they would have this experience to find out, even if you just give this material, they will know what is the speed and what is the optimum thing, and they would have figured it out. Just that they will slow it down intentionally so that they can bill you more. Yeah, so they will try to do it. So what you can do is you can ask them, you increase the speed a little bit more and see how the cut is. So it becomes a little iterative process. But if you are getting just one thing cut, then you don't have any problem.
That is technical specifications. The laser people must be knowing.
The laser people will know. Yes. Okay. Shall we go to the dive into the fusion thing? I will have to stop this sharing and then open fusion. You have any questions in the design thinking process and other aspect of design?
No, sir.
Okay.
No.
Sir, is it with only the wooden surface, or it can be with any other surfaces?
So yesterday in one of the slide, I covered this thing wherein I was using. I'd shown what are the different materials that was used. Wait one second. Yeah, so these are the materials that you can laser cut it. As long as the thickness of that material is something that laser can cut. These are the list of materials that it can cut.
Okay, thank you, sir.
Sir, can you share this link for this Fusion 360, sir?
Fusion 360 link was actually shared with you today morning, just before this thing. We did it. So I see
Yes.
some people are
Yes,
doing
it's on
annotation.
WhatsApp group. It's given
Yeah,
on
it's on the WhatsApp group. Sorry, I didn't do it yesterday. I have to stop the share so that we'll be able to see the Fusion screen. 1 second. Okay, very quick recap on the Fusion 360, since we did it yesterday and it was a new thing for most of them. So here, please don't do that annotations. Who is doing it? Okay, so I have to create one project folder, and inside the project folder, I have to save my project. I have to go and save my project. Okay, once I save the project, it comes here. You can add people to your project. Oh my God, who is doing this?
Please don't give the system to your children.
Okay. So we have a 3D space where you can do this and look at all the things that are there, and there is a timeline where every action has been recorded. You create a sketch, it creates a tab here that says you have created a sketch, you have extruded, you have built in a body that shows up. If you are adding some modifiers, then it gets recorded and can go back and edit any of those things. So I'm now turning on the origin. Now I'm creating a sketch. Okay. So I'm creating a sketch. I will choose which plane I want to do. I would want to do it in this plane, the side plane. Now I have this laptop stand with the side plate. Just a second.
So can the video be little more clear, because can't see the options, the sketch, origin, and all the options is little blurry.
Oh, unfortunately, I can't do it, ma'am. There is no options to
It's
zoom in
clear.
the text that appears. It's probably something to do with the internet speed of me and the instant internet speed of the users, other participants.
Clear,
So,
sir.
okay, thank you. So we have a laptop stand, and we know the material that I will use will be of um, uh, certain thickness. Sorry. Okay. Even before starting the sketch, I want to do this, go to modify and change parameters. So there are parameters. See, material thickness is one such parameter. I want to address that. So user parameters, I'll go to user parameter, click this plus mark. It asks what is the name of that parameter. I would say thickness. I would say thickness. I know the mm of it, and in the comment I will write how many that is. I'm looking at 5 thickness. Sorry, I'm looking at it as a 5 thickness value. Then I say okay. So this is the thickness of the material that I will get laser cut from. Now I have to know what is the width of the laptop stand. So I will add a parameter called width, and I want that to be about 30 centimeter wide, my laptop stand. So I'm adding 300 for 30 centimeter. And there's another thing where is the depth of the laptop stand, which is probably about, I want it to be some 15-20 centimeters. I'll simply do it. So you can choose what should be the length and width of the laptop stand. And this is something that I would want it to be 25 centimeters. Okay, now the height is something that I don't know how much height it has to have. So there are two height parameters, right? One is because it has an inclination, what is the lower height and the highest height. So the minimum height is what I will add. So I will write minimum height, and that would be about 5 centimeters. So I will write 50. So the minimum height is 50 now. So I have got these parameters, and I'll tell you exact reason why I use parameter instead of simply putting in and typing in dimensions. So yesterday we saw how I was typing the dimension when I was putting in any shape. I can do the length, breadth, radius. I have to just type the dimensions. Instead of doing that, I'm putting in the parameters. In the change parameter, I'm defining the user parameter, and I'll use the user parameter instead. Because with one switch of a button and one click of a button, I can change those user parameters. So the laptop stand will obviously have a base. So I'm looking at the side view of this. So we'll have a base, and that is the depth, right? What did I do? Length is what I then see. I can just click the parameter length. Okay, this is a line. I'm just ensuring it is at 0 degree, and I'm clicking, and then I can say yes to it. So I've got one line here, and I know the minimum height it should have, which is minimum height. Okay, I got the minimum height, and then I know it has to have some inclination. If you look at what is the best ergonomics to keep a laptop, you will find it is up somewhere around um, uh, 25 to 30 degrees angle, and sometimes people have done just 15 degrees also. So what I'll do is I'll go with 180 minus 30 or something like that, and give 150 degrees. So I'm pressing tab so that I can do this 150 degrees, which is 15 centimeter. Okay. Probably this 150 is a little too much. So I'm going for 170 or 160. Sorry. 170 or say 165 degrees, and I'm simply putting one line there. Okay, then I can press escape to end this thing. If I keep clicking, okay, I just pressed escape. So now I'll draw another line from the point where it started, and I'll do a 90-degree line and intersect. So intersection will have an into mark, and I will just click. So I have the side panel ready, right? And so when I place a laptop, it keeps sliding, right? Because of the inclination, the laptop might keep sliding. So I have to put one material here so that it stops the laptop from sliding out. I mean, sliding into us. So I'm putting one stopper here. So how do I put one stopper? I can simply extend this thing and say 25, and then I simply put one line, and then again I did something like this. But you see, it is looking ugly, right? That is where we have constraints. I'll go to constraints. Then there is a parallel constraint. I want this line and this line to be parallel. So it became parallel. I want this line and this line to be parallel. So it became parallel. But you see, I don't know what is the height of this. So what I will do is I'll click on D, and I want to define what is the height of this particular thing. So I want that to be like the width of the laptop. If I'm using a laptop and the laptop is this thick, I want that much thickness so that the laptop won't fall or slide. So I'm using that thickness to be about say 3 centimeter or something like that. So I'm putting it 3 centimeter. So it got adjusted. So my laptop will stand here like this. It will touch on this particular contact. Instead, it could have been like this, right? The edge of the laptop. So the side panel is ready now. So I can now extrude and make the side panel, right? So I'll do exactly that. I will finish the sketch and I will extrude now. I'm zooming out. I will extrude now. To extrude, I can go create and extrude, or I can just press E and I will select what are the profiles. Profiles is a closed area. If there is a line and there is no loop, it will not select it. So now I can do this, right? See, I'm getting a plane. But what should be the thickness of this? This is the thickness of the material, right? But for which I'm already used a parameter called thickness. So it is coming like this. But I want it to be minus thickness because I don't want to go to the other plane. So this is just one practice that I use. So I'm using minus thickness. So now I got one side panel. I wanted another side panel because I want two of these, right? So one second. So I want two of these side panels. No, nothing. Thank you. So I want two of these, right? So before designing that another thing, what I can do is I can press M, which is moving. I'll click that body which I want to move. Say I can move it, right? So I could move it. So I just reverted that action. So I'm clicking M and I'm selecting the body that I want to move. There is an option called create copy, which means when I move it, it will have a new copy and put the new copy there, and the original will still be in its original place. So I've selected this body and I want to move it like this. How much do I have to move? You have to move at least the width of the laptop stand. So what is the width of the laptop stand? I've done a user parameter. I will select that. But if I do this, I'm going beyond the thickness as well. So there is also thickness of the material. I mean, the side panels also involved, right? So I have to, be within that space. So I will write at least minus 2t, minus 2 thickness, right? See, it moved a little inwards. See, width minus, I can use the parenthesis so that I know this is what it does. So now I know how much I'm moving. Instead of simply moving 30 centimeters, I'm moving little less than that. I'm pressing OK. Now I got this thing, right? So this moved here and I want the top plane. So you see when I was using the sketches, I was using the, so I'll just turn off the body. When I'm doing the sketches, I was selecting the planes on which I used to sketch, right? But here I've created a body, two bodies. In fact, there are two bodies. I'll just rename them left and right. You can have an elaborate name for these, but whatever is good enough for you to recognize, that you can use. Okay, so I used to sketch. I was using the one of the three options that it was posing, which is the Cartesian planes. But I want a plate like this, but the plate will sit at an angle. It will sit at an angle. If you see, the plate will sit at an angle. So I don't, I can't create this and again rotate the plane for that exact thing. So when I'm creating a sketch, I will go select the inclination plane. So I'm actually sketching on that part of the plane. So I can now draw lines, I can draw rectangles. So I'm choosing from where I want the things to be. So I will start the plane from here, and then I want my laptop stand to be have this. So I will click it. So I have this rectangle here. But I know to attach these two things, my plates has to be have finger joints. So I will just do what are those finger joints. What are those finger joints my plates will have, right? And see, I could use the mirror function instead of doing it. So I'm finding what is that midpoint, and I'll draw one mirror line, and I'll go to select, I will click it and press X. So it becomes a construction line. So the next thing that I want to do is mirror. I'll mirror this loop, this rectangle, okay? And I will select the mirror line. So I selected 5, but I wanted only 1. So I mean, I wanted only one rectangle, which is 4 lines. Then I will go select the mirror line. Now I've got the same rectangle here, right?
I'm sorry to interrupt, sir, but your computer screen has become very blurred. It's very difficult to read what you are actually clicking and moving your cursor to.
Okay. That has something to do with the internet speed, ma'am. And I would like to ask if everyone is facing the same problem.
Yeah, same here, sir. We can't see it properly.
Yes, sir, I already told you in the beginning. So
Okay, I thought it is problem for few people. I'll just unshare. I will check what it is.
It is better. It is better now.
Yeah, so I just ended few things and restarted the module. So let's see. Um, so now I have these two things. I could extrude this, but instead I want the finger joints to appear, right? So what I've done is I will finish the sketch now. I'll finish the sketch. You can't see, if you can't see the sketch, you have to turn this on. So there are two things here. I can extrude this rectangle, the entire thing, and have these two tabs. But now what I have to do is the side plates needs to have some elevation so that it goes into this rectangular plate, so it sits better. So I'm pressing extrude again, and I'm clicking these rectangles. Okay, when I do this I have to do I can't do like this much. It has to be about the thickness of that the top plate, so that you can place the laptop without anything. So now I can just do the join operation. By doing the join operation, and pressing OK, you see the this body got joined. Otherwise, if you have clicked the new body, you would have had the left plate, right plate, and this the above tab and this one. So that would have caused some trouble. There is some error here. Sorry, when I extruded, I didn't select properly. That is why I had to redo it. So now I have this, wherein you can see how we have gotten this bit. Now what I have to do is I have to do the top plate. So I will turn on this thing again. Now I will select this sketch and extrude. So I'm selecting this, and how much I have to extrude? I have to extrude the thickness. So now I've that extruded the thickness. There is some problem. See, when I create, okay. So, sorry, when I'm extruding, I have to select the profiles, right? So I have to select the profiles. But there is some mistake in my drawing, which is not aligning. You see, there is lead line coming. So there is some mistake. So I didn't do it properly. But for time being, I think I will hit yes, and I will mention it to be the thickness. And I'm clicking OK. And I don't want to join. If I join, it becomes one single unit, and you can only manufacture it using 3D printer. I can't do laser cutting because it becomes one unit. So I have to do new body, right? I do new body, then I have this 3 plates now. This I will rename it as top plate. Okay. So I've got 3 plates. We have the laptop stand, about ready. But I see what the problem could be. The problem would be these 2 side plates. It could fall apart like this because the finger joint is on the edge. The finger joint is not in the proper place. It's not in the proper place, and that's not how we should have designed it. Okay, there are few chats. It's clear now. It's not clear. Okay. So in order to solve that, I will have one reinforcement from the bottom so that these 2 plates are getting attached, right? So what I have to do is I have to create another sketch. I would want to create on this plane. I will go create on this plane. And here I would want to have one rectangle like this. I would want to have one rectangle like this. Okay. Now that I have created a rectangle, I can do an extrude function. Then I'm extruding on both the sides. I will extrude little on this side, on the 2 sides on the other side. I will take it all the way to here. You can give actual dimensions and make it very symmetrical. So I'm doing this. Okay. So I have one rectangle or one piece of wood that is running throughout, but there is one problem to this. It is now cutting through the material. I don't want to cut through the material. I want it as a new body, and I'm pressing OK. But as you can see, there is some interference. Interference means there are 2 objects that are occupying the same space. There are spaces where 2 objects are occupying, right? So when this happens, how you can find out if there are an interfering thing? You can go to inspect, then you can click the interference. When you click interference, what are the things that you want to select? these three things and find out if there are interference. Then I will just click compute. It will show those things which are interfering. So there is a red volume of the cuboid which is getting interfered, and there is a green. What are those things? So it is about this volume that is getting interfered with this body 4 and laptop stand. In this, what are the bodies that are getting interfered? The left and the body 4 and the right. So this is the body and it is getting interfered with both of these things. So I have to modify that. So there is something called as finger joint or intersection joint. So that is what I am intending to do with this thing here. So again, I go to the bottom and I will do this. I will turn off the body, but I will create one sketch here. So I will create a sketch on this plane. I will turn on the body so that I will see where I have to draw that rectangle. So I'm drawing a rectangle. Okay, I'm drawing a rectangle. And I'm also drawing a rectangle here. I could have drawn one. See, I'm not doing it accurately, but I'm doing it because I will run out of time otherwise. I have to cover how to export and arrange those things so that you can laser cut and save space. So I'm doing this. I've got two of these things, and I will turn off this link. And what I'm doing is I'm pressing E so that what I do, I will select these two things. I'll select these two things. Now what I'm doing, I will cut it. So I will make this thing. I'll do little, and then I will press OK. So what I have here is two cuts like this. So I have two cuts like this. And when I turn on this body, there is still interference. I'll go and see if there are interference. I have to select what are the things that I want to inspect, and then I will press compute. There are still interference. See, there are still some interference. So what I have to do is I have to do an operation called binary operations, wherein there is options like combine, right? So I will do this. Yesterday also we did this combine feature. So what is the target body? The target body is this. What are the tool body? This and this. What should I do? I have to cut. And if I do this, the tool bodies are gone. You can see it's already leaving an empty volume. So I want to keep the tools and then press OK. Right. So now when I press M and want to move this thing, then you will see I've created an intersection joint between the two planes. I mean the parties here. So what happens is I don't want the move to happen. So you see the laptop stand is about ready, but I see a lot of sharp edges. So I would want to fix it using the modify thing wherein I can do fillet. Fillet is that round thing that I do. I mean, so that there are no sharp edges, and I'm just selecting the edges that will require the fillet. So these are the few of the edges I think will require fillet, so that there are no sharp objects, sharp bodies. So I'm selecting all the edges that I can do apply fillet. Okay, I want to do this fillet and see which looks better is what I would go for. I think this is good enough. $15 looks fine. Yeah, I'll do this. I'll look at all the other angles that I could see. I think this is better. I'm gonna click OK. Okay, now how do, now all of these are bodies. Say this is the reinforcement we built. I would say bottom. So I have this laptop stand with me, and I see if I place the laptop, the laptop might get heated, right? So there are no vents for the fan. So you would have a laptop with a lot of the fan that will come that will push out the hot air. So I have to design something so that there is some gap in on top of this. If you're using it as a table where you can draw and write, then this is fine. If you're using just for the laptop, then it is better to have some vents. So I want to create one sketch here, and I will so that you would have seen a lot of fancy things, but I'll try to do one or two things here. So I'll just click 3 points like this, right? So that is one vent. Okay. There's another thing that I want to do is like this. I can even move this around. I can even move this around. Okay. Now we'll look at one more thing. Instead of, see, there are only two vents. I want a pattern for this. Instead of drawing more of this, what I do is I will go to create. Then there is a pattern. So we'll look at rectangular pattern. Hey, somebody is doing this. Please stop. Otherwise, I have to stop sharing the screen. So I'll select this, and I can now increase this distance, say 50, not 50. I can give 30 and see what is happening. 30 is not good. I will say 100. Okay. Or 150. And here I would want to do 2, and I want. So this is a rectangle pattern. So it is telling, it is now creating the pattern of this here on one plane and again here. So I can use these things to adjust where these things are, or I can manually enter how much that is. So I want more quantities. I can click these and get more quantities. See, now I'm creating vent. Okay, when I'm okay with this, I'm clicking okay. But there are other things that also, I mean, I did this to so that I can show what is that circular pattern. So I will click the circular pattern. I will double click this so that I select this thing. And what is that axis it has to rotate about the center point? I would choose this, and then you can see I can make a circular pattern. I can make a circular pattern. I don't want the full circle to happen because it is interfering with these vents. So I will go to some angle. I would say 90 degree. Okay. But there is something that I did, so it is not good. So I'm going to press Ctrl Z, and again I will go back to the circular pattern. I will select this loop. I don't want the full. I want some angle. I want to select the center point to be this. Yeah, now it came. So there was some problem. I would say 120 degrees. I'm okay with this. So I want the vents to be like this. you can create more of these vents in whichever this thing possible. So I don't want to do anything right now. I just want the cuts to happen. So I'll press extrude and I will select all these where the cuts needs to happen. Okay. Now I want to cut it. See, if I just go down, I will just cut it. And if I extend it more, it might cut through this body as well. If there are any other bodies, it might cut through that as well. So I just want to cut the top body. So I started the sketch on the top plane, and I will just select the bottom plane. So it will just cut that thickness. Then I will press hit OK. So you have created a laptop stand with air vents. Okay. So this is something that I am happy with. I can get it laser cut. I don't know how it will turn out to be, but I want to try how it comes out. It's okay if my design fails. I'll again do the design thinking process and have change the dimensions and things like that so that it looks better. So there are 4 bodies now that I have to create drawing for each. Instead, what I do is what I do is I will go to modify, and there is yeah. So now our laptop stand looks like it is made out of metal, but instead we are actually doing it in wood. So even to get a feel of how it would look, you can add appearances. So you press A for appearance. If you click A for appearance, in this design, it is using some steel material. I don't want the steel material, but I want to add something else. I want the wood material. I'm clicking what is that wood. I think I'll go with pine or semi glass oak wood or mahogany. What are the options? Whatever options that are available. You can even go download it and use it. So I want the pine that I'm putting for each of these materials, each of these bodies. I'm making it pine. So it looks like it is wood. So once I'm done with it, I'll just close that appearance tab. I don't want to look at it again. So the shortcut for appearance is A. So now I have a laptop which looks like it is made of wood and laser cutting. Now I have to prepare the file for laser cutting. I'll just take another 5-10 minutes to arrange this. So the arrangement is see when you look at from the top angle, right, you will see that it is not the true size, true dimension. If I export it right away like this, you will see there are 2 laser cut lines. See these edges. So you are getting perspective as well. So when I export it as a drawing, I don't want to see that perspective because laser is a 2D thing. It will not cut at an angle. So I have to have one plane where everything is laid out flat, and that is how it will laser cut. So there is a modifier called align. I'll go to align. I want to align all the objects in one single plane, right? So from this plane, I want, so I want all the objects to be in one particular plane. So I want this also to be in this plane, the reinforcement bottom plane to be in this plane, everything to be in this plane, right? So I will click this and to which plane I want that. Okay, now I have these 2 things from this to that, right? And this is already in the same plane. I just have to move it around. So the other changes that I want to do is okay, sorry, I have to commit. Yeah, this happened. I'm okay with this. There is interference. I'll move it around later. Now I have to do this again for the other part. So I'll go to align. I will select from this plane to this plane. So even that came into the same plane. And although this is from one view, even this side plate also looks like it is the same. I still want to do just that so that all of that is in one single plane. So even that came into this one single plane. Now everything is interfering. I have to move it around. These are bodies. I can't simply move it around. If a body is something that is a product of, from the sketch you extruded and you got the body. But component, there is something called as component. A component is an end product that you can get from a body, where you can, have functions like assemble, joint. You can make a joint. You can move it around very easily. So I want to do the convert the bodies as components. I'll go to this bodies and I will right click. I will get create components from bodies. I'll just do that, and all my bodies are now converted to components. So once I click a component, I can move it around. Okay. So when I move it around in a 3D space, it will move in all the axes. I don't want that to happen, so I will move it around in just one plane. Okay, I'm just moving it around like this. Yeah, so I'm moving it around like this. So, but still I'm not happy. I still want to rotate all of this. I have to arrange in such a way that this design, when you give it to the people for manufacturing or laser cutting, they will simply have to upload this code to their drawing and they will laser cut it, so that I don't place my components wide apart. If I have to place my components like this, right? If I place the components like this, which means I need this big material sheet of board to cut this. Instead, if I place it like this with no gaps, what will I get? I'll essentially save a lot of material.
But the design you have showed, you have some perforations on the top board. I mean, the rectangular portion where we'll lay the laptop. And in the actual design which you showed, there were no perforations like.
Perforation is this
Yes.
one you're talking about?
Yes,
Because
yes.
I wanted to create a laptop stand. So say if I don't want this, I'll just go back in the timeline where I created those perforations. So this is that extrusion that I know. I remember this is the extrusion where I did the perforations. So I'm
Yes.
going back there. See, I see I did that perforations thing. So I created a sketch and I did the perforations, right?
Oh,
I
yes.
don't want that perforations to happen. So what I do, I'll just go there and I'll click delete. So I don't have the perforations now.
Right, right. But what I wanted to say is that the actual laptop stand which you showed us,
Yeah,
that didn't had these perforations, right?
exactly. I will try to show that actual laptop stand as well. And I'll show you how many differences we have. See, see, in this laptop stand, the finger joint is given here.
Yes, yes.
The finger joint is here. So the side of the laptop stand is within the dimensions. Even this is within the dimensions. If I had to do this, it would take a little more time. I have also added one small drawer wherein you keep components.
Right,
If I have
right.
to design this, it will take a little bit more time, and I have to extend it beyond my time. So, and again, lunch break, I'll be encroaching on the lunch time. So I didn't want to do that. So I thought, okay, let's do a very simple thing instead of elaborating on the laptop stand itself.
Got
It's yeah. So that is why I hurried and did a very simple thing. It may not work, but I simply did it. So you got an idea. Okay, you do these modifications and you do all of this, then you will get it. So that is the idea here. Okay.
Okay.
Once I have the laptop stand, I have to send it to people, right? So I go to drawing from design. So you see all of the components are in one single plane with a particular orientation, and all the gaps in between the two plates are also kept minimal, so that when they laser cut it, the wastage material is not so much. I have arranged it properly. Now I have to create this drawing. I will create what should be the maximum size and within which it has to sit. And I will click OK. It is saying full assembly. If I don't want full assembly, I can select what are the ones that I want. If I have to select just this thing, I can create just the drawing for this one part and send it. And suppose you have one part, I see there is one error in this part, wherein see the line is coming here, which means I have not extruded properly. When I was doing this cut for the intersection, I didn't do it properly. The rectangle was not aligning with it. So what happened was there is a line here. When I laser cut, it will cut through here also. Every line it will cut. Every edge that it shows up, it cuts. So probably this is a mistake, but I'll cut it anyways, and then I'll try to fix it again the later stages. Because now that I know, okay, I can create any body of any shape, any size, anything, I can make changes. Then I'll simply hit OK now for now, time being. Then the drawing interface opens. This is where you place the component. So look at the orientation. If it is isometric or something, your laser, you will end up getting a part that is skewed like this. If you put the thing and create drawing, this is the laser cutting. This is the shape that you will end up getting. So just be careful as to what is that plane you arranged. I arranged all of that in the front plane, YZ plane, if I remember properly. So this is what, and you look at the scale. If you have 2:1, which means you have essentially, designed it for 60 centimeter width and 10 centimeter thickness material, which is unrealistic. So you have to see what is the scale that you have to do when you're designing and when you're committing to it. So I want all the edges to be visible. I mean, this is what visible edges is where I'm going for. And then tangent edges, it's okay, it shows up. Scaling is something. Thread edges, interference edges, fine. Once I'm done with those settings, I will commit where I want the drawing to be placed. I will click one button and it says OK. Then I am pressing OK. I don't want these other things. If I'm taking a printout, probably yes, there is a created by who did it. You can have a date and approved is what is the name of the drawing, when did you create, all of that. And this is also a scale that is there. It gives a perspective as to what is the dimension that you created. I don't want those things, which comes, pre-installed. It's always there default. So this is the drawing that I want to export it to a laser cutting guy and get it cut. So what I do, I just press output PDF and you get it. All the sheets, yeah, I didn't create more sheets, more drawings. I'll just open the PDF once it is done. I'll select current sheet. Set OK. So this is the drawing that I have. Wherever there is line, there is the laser will run through that line. So this is the part that you will get. So you are getting 4 of these parts. You see there is a mistake here. A line was not supposed to be here. If there is a line, it will cut through. You will end up getting one rectangle, one semicircle, and another rectangle. That line should not have been there. So you have to go back in the design and edit it. So I will not do it now because it's a little bit time consuming. I have to figure out what happened and how that mistake happened. Okay. Now that I've prepared my file for laser cutting, I want to see if I can animate this assembly. See, if you give this to a kid, he would not know what to do with this, how it looks. So there are 2 things that you can do. You can, go back in timeline. Go back in timeline and see you have an assembled thing. Then I can go click render. In the render, see, it looks little different. You are not seeing the edges. In the render, I can set up the scene setting wherein brightness of this thing is you can adjust. What is the background? Solid color. If you click solid color, 1 second. Yeah, if you click solid color, I want the background to be white and press OK. If I want the background color to be black, press OK. See, background is black. So, and you can also put images or even have environment library. So this environment library is where you see how the light is interacting. This is made of wood, so you're not seeing the specular reflection or the light and the shadow, those things properly. If it is metal, you would see where that thing is placed. You can even have these field. I have not downloaded. Once you have this, the laptop will be placed on the field, or the laptop will be placed under this snow field, or it will be placed on this road near the plaza. So you have that environment setting where you can change those things. And once you're happy with the settings, then you can click on the render. When I click the render, it asks what is the image where I have to save, what is the aspect ratio that you're looking for. So I want a 16:9 HD definition, this thing. Then I can click render. Render quality could be standard and final. If it is final, there is something called as credit points. Once you install Fusion, you will be given few credit points because it's a few software. Free software, open source software, and people keep on using their tools for free. Now what they have done is they have tried to monetize the free software, and what they have done is they have credit points. They give you credit points, and every time you render very high quality thing, it will take 20 minutes queue. There is a queue time. After 20 minutes, it will start rendering because it's a cloud process. There are thousands of people who are designing and rendering at the same time as you speak. So when you have enough credits required, only then you can render. This requires 1 credit point. So if I go for standard, which doesn't require any credits, but it will still require 10 minutes because the process is still happening over the cloud. So this is where you can do. So if we are, you can even render a video or for a mobile and for a web. What are the for what purpose you are rendering it? So once you are ready with the render, you just click render. You get a nice photo of this as a PNG or JPEG. That is about render. I can go to animation. If I have to go to animation, you can't animate a body. You have to animate a component. So if your design has a body, nothing will show up here. So you have to go to design. If there is any bodies, you have to convert the bodies to create components from bodies. Then go to animation. So now you got it. So when I'm animating, see, I did one motion. So there is a timeline. So after say 6 seconds or 7 seconds, I want the zoom to happen. Okay. So what is happening for the next 7 seconds? I'm doing a zoom. Okay. After 1 second, I want the pan to happen. See, it created. Do you see how it is happening? So I'm animating the laptop. And I can even do this and do this. So I'm animating the laptop to look at from different perspective. I don't want the view angle to change, which means I can click the record button. I can pause the record button. The next thing is, okay, I'll mute somebody. Okay. Now I want to show how the animation is happening. So I will press one component and I'll press M and I'll move it. And I'll press this thing and I will move it. And I'll press this and I will move it. I'll press this and I move it. So there is an animation happening. Okay. I have to select OK. See, do you see how the animation has happened? So you have all the parts like this animating. Now I will call in one part at a time. Hello, can you hear me? Are you able to see the screen?
Yes, sir. Yes, sir.
Yeah. So I go click on one of the component. I say restore home. When I started the drawing where I was, that is the home position. Now it has come back to its home position, right? Then I will call this thing and I'll go ahead in time. Then I will go and call this to home position, restore home. Okay. Then I'll go further ahead in time. I can even So these are the keyframes that has happened. When the timeline goes through this, when it comes through this movement, that is where that component, say top plate, you see the top plate here, and then there is a keyframe that is created. So as the time frame elapses, you will see that motion happening for that each particular thing. Okay. Okay. I've been told it is time, so I will just complete this assembly animation. Okay. Then I will restore this as well. And then again, I'll go ahead in time. See, I can move this tabs around. Okay. Then I can even adjust the speed at which it comes. Okay. I'm moving ahead in time. This is the final part that I have to do. I will go click restore home. So if I play this from the beginning, I don't want the video camera to animate, so I'm just deleting the video camera animation. I just want to see how all of this. Now I don't, I can move it, I can select and move it around the timeline. Okay, now I just hit the play button. You will see how it exploded. Now I'm calling each part and an animation is happening. So now when you show them this video and give them the parts, they'll be able to assemble this model themselves. This is about animation in Fusion. Now it looks like it is like, it is one angle. If I have to show it in detail, then you know what I do? I just click the record button for the camera. Okay. Then what animation it needs to happen after this second? It has to, my camera angle is fine for now. Here when it is happening, I want the camera angle to do like this, because this is where the action is happening. I want to look at it this way. So my camera was like this. When the side plate was coming, I'm rotating it and showing it. I don't want this thing here. Okay. So the side plate is coming, and by the time it comes, I'm zooming into that part. Again, when this is happening, this let the side plate come. By the time this joins, I want to zoom into this part where the joining is happening. Now this animation is pretty slow. So what I do is I'll speed the camera movement. Yes. Okay. So I have this animation happening, then this animation happening. Now I'm looking at it at a different perspective as well. When this was happening, I was supposed to zoom out. So I'll just zoom out and I'll press home and I'll zoom out. Okay. Now I'll just hit the play button. You would see how the animation happened. Just one more minute, I'll be telling how to export this thing. So once
is there any time limit for this animation?
Ma'am, it depends on what is the RAM, because if your RAM is less, then after some time, say if you're going beyond 20-30 seconds, just to move one object, it will take a lot of time. You will see a lot of hang happening.
We need to set it before itself.
No. You don't have to set it before.
Yeah.
You just keep on animating. It keeps on happening. It is endless. It depends on the. So there is a maximum upper limit. I don't know. I have not reached that maximum upper limit. Usually 3 minutes, 4 minutes is something that we have done already. So this animation you can do. So, and if you have a wheel or something, there is one more thing that you can do is you can rotate it. So I'm just clicking this component. I'm using this rotate feature. I know it is unrealistic for this model, but I'm just telling because rotation is possible. So you can have, once this thing happening, you can have just the toplet rotating. So you can have the wheel rotate, and the student will go like, wow, this is so nice. So you can use these tools and you can create these animation. You can have the robot model itself and do a lot of, it will help in assembly. It will help in, visualizing. It will help in whether this thing will work or not. So once I'm happy with this, I can go publish the video. So it asks what are the resolutions, the current document size, or what are the other options. You click on those things and it has all storyboards. So you can even create more storyboards. So you can save and it saves. So you can even save the animation, you can publish and you can have the video and you can even put it on YouTube and share it on WhatsApp. So that's about animation. And I think we are at the end of this session. I think I took at least 4 minutes more than what I planned for. You have any doubts regarding any of these things, you can ask me. You can ask now. Okay, there are a few questions in the chat. I'll just go through. Thank you, sir. This is really
It's fine, but it requires a lot of practice. It requires a lot of practice.
Yes, ma'am, but it is worth it because you are able to create your own laptop stand, robot, pen
It is
stand.
fine, but until and unless we do it on our own,
Exactly.
So we need to do it on our own, and then only we'll be able to understand how far we can do it.
Correct. So once you install the software, you spend at least 30 minutes a day. That's the least that it requires. 30 minutes a day for at least 1 week you do, you will reach some, you will have some results. Then you'll be at least confident then, okay, I can build something like that. So
Right.
I'll keep sharing few videos about Fusion 360, what other people have done, what we have done. And if you just go through the time-lapse video as in how they have done it, you will get it. I mean, it is very easy. I know it is new and intimidating at the beginning, but it is very easy. It will become a second nature. It is almost like riding a bicycle. That's how it is. And any implementation software or tool, that's how it has to become. You will never think about how I'm holding a pen. You will simply write it, right? So that's how even the Fusion 360 has to become. If you want to design something, it has to become second nature for you. And for that, there is no other shortcut unless you start practicing on this.
You'll be sharing the links of the videos you are telling in through our mails.
In the WhatsApp chat, I'll try to post some of the videos. Then I would recommend somebody called Lars Christensen. So he was the one who started, posting a lot of these tutorials on Fusion. So he started posting a lot of these things on Fusion. I mean, the tutorials on Fusion, and there are lots of followers asking a lot of questions to him, and he keeps posting new videos addressing those questions. He was pretty active at some point, and he has built some really good models. He has explored almost all nooks and corners of the Fusion software, and there's lots to learn from his series of videos. So I'll post one video from him, and you can take it from there.
Please repeat the name which you told. Please repeat the name.
Lars Christensen, Lars, and then Christensen.
Okay. Thank you.
Thank you, sir. Thank you so much.
Yeah, thank you, ma'am. Thank you.
Thank you, Vaibhav, for your very technical session. Very interesting. You made it very interesting.
Yes, ma'am. Thank you.
Thank you,
I think my session for ATAL has come to an end. This was my last session. So
Okay.
I'm very humbled, and I thank you for this opportunity that I had so that I could share whatever I knew. I hope I didn't waste people's time, and I inspired people to take up one skill set that like a 3D model and incorporate in their curriculum and pedagogy so that more people learn such software and make a good use of it. I hope I've inspired at least one or two people, if not everyone. And
Sure,
thank you, ma'am.
Really, sir, you inspired us.
Sir, bye-bye.
Thank
For sharing your knowledge.
Thank you so much.
In this
Yes.
ATAL 5 days FDP. Thank you
Yes,
so
ma'am.
much.
Thank you so much.
Thank you, sir.
Thank you. Yeah.